Hi, in this video I'm going to go over the Algebra Level 3 mock paper that we did. Right, question number one. Our first question was to expand and simplify this expression over here. So we're just going to multiply this out. So I've got 2c times 2c, which gives me 4c squared. 2c times 3d, which is 6cd. I've then got this 3d times the 2c, and it's going to be a subtraction, so it's going to be take away 6cd. And then I've got 3d times 3d, which gives us 9d squared. But remember, it's going to be take away here, so it could be take away 9d squared. And you might spot that we can simplify this because 6cd, take away 6cd cancels each other out. So I'm just going to have 4c squared, take away 9d squared for that one there. On question 2, we want to simplify this here. So I've got y to the power of a negative a half and then taken to the power of negative 6. So my laws of indices tell me that I just multiply these two things together. So I'm going to have negative a half times by a negative 6, which is going to give me a positive number. Half times a 6 is 3, so this is going to be y cubed. Okay, this next one over here, we're going to simplify this expression over here. So first of all, I've spotted that I can do 4p squared, add 5p squared, because that's going to give me 9p squared. So I'm going to rewrite this as 9p squared, and then I'm going to take that to the power of 3 halves. Okay, so this is where I need to be careful, because that means I need to do 9 to the power of 3 halves, and I also need to do p squared to the power of 3 halves. So 9 to the power of 3 halves, that's going to be, that number there is telling me to the square root of 9, and then I want to cube it. So the square root of 9 is 3, I then cube the 3, and that gives me 27. So the number part's going to be 27, and then to do this part here, I could just do 2 times 3 halves, and 2 times 3 halves is just going to give me 3. So this part is going to be p cubed. So I should have 27p cubed for that one there. Okay, right, the last part of this question, I want to express this as a single fraction in its simplest form. And this question here is worth 3 marks. So what I want to do is I want to get a common denominator for my fraction. Okay, so there's a few ways of doing this. What I'm going to do is, because I can see this x plus 2 squared over here, I'm going to make this x plus 2 squared by multiplying it by x plus 2, but that means I need to do the same thing to the numerator. So the numerator is going to become x times x plus 2, and then the denominator here is going to become x plus 2 squared. Okay, and now I've got the same denominator over here, because that's going to be x squared over x plus 2 squared. Okay, so now I've got a common denominator. I can just do the numerator, subtract the numerator. So I'm going to leave this as x plus 2 squared. I'm not going to bother factorising that. Sorry, expanding that. And then my numerator, I'm going to have x times x plus 2, which I'm just going to expand now. So that's going to be x squared plus 2x. And then I've got to take away this x squared. Yes, all I've done is I've done this expression, take away this one, but I've expanded it at the same time. And what I can spot here now is that x squared take away x squared are going to cancel each other out. So on my numerator, I'm just going to be left with 2x. And my denominator is going to be x plus 2 squared. Okay, and I don't need to expand that out. I would leave it like that, and that doesn't simplify any further at all. Right, on question 3, you can spot on here that there isn't a common factor across all of these, but what I have spotted is that this part has a common factor, and also this part here has a common factor as well. So I'm going to factorise this in 2 separate parts. So I'm going to do the 2wt plus 6w, and I'm going to factorise that part first. So for that, I can see that 2w is a common factor, and then inside my brackets I'm going to have t plus 3. So if I expand this out, I'll get 2wt, and that gives me the 6w. Okay, and then separately over here, I've got to take away. So I'm going to put my take away sign in there, and I can see there's a common factor of a 5 here. So 5 is going to be outside my brackets, and inside my brackets I'm going to have t, and because I want this to be take away 15, that has to be a plus, so it's going to be plus 3. And can you see now that I've got a common factor of t plus 3 and t plus 3 over here? So if I factorise this, I'm going to have 2w take away 5, and then inside my brackets I'm going to have t plus 3. Okay, so my answer for that one is going to be 2w take away 5 times t plus 3. Okay, the second part of this question, I want to factorise 8gh cubed take away 6g cubed h squared. Okay, so for this here, I'm just going to look for the common factors. So if I just look at the numbers, the common factor of 8 and 6 is going to be 2. And if I look at the g part of this, I can see that the common factor of g and g cubed is going to be g. And then the common factor of h cubed and h squared, so the highest common factor is going to be h squared. So that's going to be outside of my brackets. And inside my brackets is essentially, what do I multiply this by to give me this? So I need to multiply it by 4. I've already got the g, but I need that h squared to be an h cubed, so I need to multiply it by an h. I'm then going to take away, and I need to multiply the 2 by 3 to make it a 6. I need to multiply the g by the g squared, and that h squared I've already got, so I don't need to multiply it by anything, so I'm just going to have 2gh squared times 4h take away 3g squared. Okay. Okay, on to question 5. I've got this equation here that I'm looking to solve. Okay, so I can see at the moment I've got fractions in my equation, so I'm going to try and fix that, and I'm going to try and get rid of all the fractions. So in order to fix that, I'm going to multiply both sides by x plus 2 to get rid of that fraction there, and I'm also at the same time going to multiply both sides by x take away 4 to get rid of the fraction over here. So if I do that, and I'm going to do them both at the same time, that means the x plus 2 is going to be gone from here and it's going to appear over here. So that's going to be 2x times x plus 2 equals, and then the x take away 4 is gone from here and it's going to appear over here. So it's going to be x times x take away 4. Okay, so now I've got an equation that doesn't have any fractions in it. Okay, so I'm now going to expand the brackets. That gives me 2x squared plus 4x on my left hand side, and my right hand side I'll expand the brackets and I've got x squared take away 4x. Okay, so I'm now going to try and, I can see that this is a quadratic equation, so I'm going to make it equal to 0 as I normally would do with a quadratic equation. So I'm going to subtract x squared from both sides, so that gives me 1x squared over here, so I subtract x squared, so that's going to be 1x squared. I'm also at the same time going to add 4x to both sides, so that's going to give me plus 8x. And that means on this side I'm going to have 0. Okay, so I've subtracted the x squared from both sides and I've added the 4x to both sides to make that 0. Okay, and this is where we need to be careful, because I think sometimes you get caught out with this. I've got x squared plus 8x, that's got a common factor of x. Okay, so it's a quadratic equation, but this particular one, we haven't got a number on the end, so we've just got a common factor that's going to be x. So I'm going to take that out, and that gives me x times x plus 8 is equal to 0. Okay, so now I've got it in factorised form, and I need to solve it. So there's two possible solutions here. I've got two things that multiply together to give me 0. So either that x is going to be equal to 0, or this x plus 8 is going to be 0, in which case x would have to be equal to negative 8. So my answers here are going to be x is equal to 0 and x is equal to negative 8. Okay, question 6. A straight line passes through the points with coordinates 3, 1, negative 2, 5. And we first of all just need to find the gradient of that line. Okay, so what I'm going to do is I'm going to write the coordinates on top of each other. So I've got negative 2, 5. And remember, to work out the gradient, we need to do the change in y divided by the change in x. Okay, so that's what we want, the change in y divided by the change in x. So I'm going to see how much this y coordinate has changed. Okay, so I can see here that it's gone up by 4. Okay, I also then need to see how much the x coordinate has changed, and I can see that the x has changed because it's gone down by 5. Okay, to get from 3 to negative 2, it's gone down by 5. So the change in y is going to be positive 4, and the change in x is going to be negative 5. Okay, so my gradient is going to be negative 4/5. Okay, part B, it says find an equation for this line, and we need to give our answer in the form y equals mx plus c. Okay, so I already know the gradient, okay, so now I'm going to use one of the points that I had earlier to then work out what the c is. Okay, so let's write down what we know so far. So y is equal to the gradient, which is negative 4/5 x plus c. Okay, so my job here is to work out c. Now I'm going to use the coordinates 3, 1 to help me here, because I think that's going to be a little bit easier. Okay, so the x coordinate is 3, so I'm going to say when x is equal to 3, the y coordinate is equal to 1. Okay, so that means that if I put that in, the y is 1, so 1 is equal to negative 4/5 of x, which is 3, plus c. Okay, so that means 1 is going to be equal to, and I'm going to do negative 4/5 times 3, which is going to be negative 12/5 plus c. So I now want to add 12/5 to both sides of my equation here. So remember, 1 is just 5/5, so I'm going to do 5/5 add 12/5, which gives me 17/5. Okay, so that tells me that c is equal to 17/5. So I can now go back to this equation and I can write down what it is. It's going to be y is equal to, and in fact I'll write it over here, y is equal to, and it's going to be negative 4/5 x. And then we're going to, the c is a positive 17/5, so we're going to add 17/5. Okay, and that there would be my answer. Okay, in question number 7, we are given a speed time graph for a walker. Okay, so this is the graph here, and we can see that we've got the speed going down the y-axis in kilometers per hour, and then we've got the time in minutes going from 0 to 20. The first thing we want to do is write down the acceleration of the walker for the values between t is equal to 0 and t is equal to 20. Yeah? So what is the acceleration of the walker between these two times? Well, you can see that the speed isn't changing during those times, it's just staying 6 kilometers per hour. Okay, so that means that the acceleration is going to be constant. Okay, so it's just going to be 0. Okay, so it's just going to be 0, and it's going to be kilometers per hour squared. Okay, but we could just write 0. Let me just get away with writing 0 for that. Okay, and then, sorry, just the other thing to just point out there then, and we can see, remember that the gradient is what tells us the acceleration, and I can see that with a horizontal line, I just have a gradient of 0. Okay, so it's just going to be 0 kilometers per hour squared. Okay, part B says find the distance walked between t is equal to 0 and t is equal to 20. Okay, so this time I want to work out the distance. So now we need to remember that the distance in a speed time graph is given by the area. However, in this particular question, we've got the speed in kilometers per hour here, but over here our time is given in minutes. So what we need is we need our time in hours. So I would work out the area under here. So I would normally just do 6 times 20, but because we need this in hours, I'm going to use, instead of 20, I know that 20 minutes is 1/3 of an hour. So I'm going to use 1/3 over here. Okay, so that means that it's going to be 6 times 1/3. And 6 times 1/3 is going to be, well, it's like doing 1/3 of 6, which is just 2. Okay, so that means that the distance walked is just going to be 2 kilometers. Now, you might have done 6 times 20, which gives us 120. Okay, and you would get 1 mark for that, but then you would need to convert that, and what you would need to do is just divide that by 60 at the end. Okay, so you can still do it that way, but you just need to remember to divide by 60 in the end to convert it. Okay, so what we should have there is 2 kilometers. Okay, part C of this question, it says on the grid below, we need to draw a distance time graph for the walker for values t is equal to 0 to t is equal to 20. Okay, so we're now converting this into a distance time graph. Okay, so I know after 20 minutes he has travelled 2 kilometres. So what I'm going to do is I'm just going to make up a scale over here, and let's say that's going to be, we'll just make it nice and small here. So let's say that's 1, 2, and this is going to be my distance in kilometres. Okay, and it's going to start at 0 and it's going to move to 20. So it's going to, after 20 minutes, it's going to be at 2 kilometres. So I'm now just going to draw a straight line that goes through those points there. Okay, and then that would be the distance time graph for that question. Okay, question 8, we need to find the sum and the product of the roots of this equation here. We've got half x squared plus x plus 1 is equal to 0. Okay, so it's already written in our quadratic form, equal to 0. So I'm just going to write down what the values of a, b and c are. So a is going to be a half, b we can see is equal to 1, and c we can see is equal to 1. Okay, so to work out the sum of the roots, so I need to remember this, the sum of the roots is given by negative b over a. And to work out the product of the roots, again we need to remember this, that's going to be given by c over a. Okay, so let's do the sum of the roots first. So negative b over a is going to be negative 1 over a half. So we want to do negative 1 divided by a half. Okay, so I know that there's 2 halves that go into 1. So in negative 1 divided by half, it's going to be negative 2. Okay, c over a, that's going to give me, let's say 1 over a half. And then again, I can see that 1 divided by a half, that gives me 2. Okay, so the sum of my roots is going to be negative 2 and the product of my roots are going to be 2. Now another way I could have tackled this is that if I didn't like the fraction there, I could just multiply the whole thing by 2. Because it's an equation, I can do that. So if I multiply everything by 2, I would lose the fraction. So that would make that 1x squared, that would make that 2x, and that would make that 2 is equal to 0. Okay, so then my values of a, b and c would be different. I would now have 1, 2 and 2, but it would make these calculations easier because negative b over a would be negative 2 divided by 1, which is negative 2, and c over a would just be 2 divided by 1, which gives us 2. Okay, but either way, my answer is going to be negative 2 and 2 for that one there. Okay, the second part of this question, we're given a different quadratic equation, so we don't need to worry about the first part anymore. And that's x squared plus a half x plus c is equal to 0. And we're being told that this equation has 2 equal roots. Okay, so they're both going to be the same as each other. And now as soon as I see this, I need to decide on my discriminant. Okay, so my discriminant is going to be given by b squared take away 4ac. And because they are equal roots to each other, I would need my discriminant to be equal to 0. Okay, so the b squared take away 4ac has to be equal to 0. Okay, so I want to find the values of c. So let's, first of all, let's write down what a, b and c are. So we've got a is equal to 1, b is equal to a half, and c is going to be equal to, and it's just c, it's just there called c. Okay, I'm now going to write down what my discriminant is going to be, but remember I want to make it equal to 0 because I'm going to form an equation with it. So b squared, that's going to be a half squared take away 4 times a, which is 1, times c, which is just c, and I want that to be equal to 0. Okay, I've now set up my equation. A half squared I know is a quarter. So a quarter take away 4 times 1 times c, which is just 4c, is going to be equal to 0. I'll add 4c to both sides, so that tells me that a quarter is equal to 4c, or 4c is equal to a quarter. And then I want to divide both sides by 4, so that tells me that c is going to be equal to a quarter divided by 4, which is going to be 1/16. Okay, so my answer for this one, c is going to be equal to 1/16. Okay, so in order for this equation to have two equal roots, that c value would have to be 1/16, and that would make it have two equal roots. Okay, question 9, we're told f is inversely proportional to d. So as soon as I see that, I'm going to write down an equation. So f is going to be equal to, and it's inversely proportional, so it's going to be k divided by d. Okay, so I'm just going to take that straight from the question. I'm being told that f is equal to 20 when d is equal to 0.25. So this bit of information here is only there to help me work out what k is, because I want to write a formula for f in terms of d. So I want to write this again, but I want to write k as the actual value that it needs to be. Okay, and I'm going to use this information to work that out. So when f is 20, d is equal to 0.25. So I'm now going to use that information. I'll replace the f with a 20, and then I'll substitute the d for a 0.25. So that's going to be k divided by 0.25. Okay, and to work out what k is now, I need to multiply both sides of this equation by 0.25. So 20 times 0.25, or remember 0.25 is just a quarter, so essentially we're doing a quarter of 20, which is 5. So that tells me that 5 is equal to k, or k is equal to 5, and then I can write this formula replacing the k with the 5, and that tells me that f is equal to 5 divided by d. Okay, the next part of this, we're given this this formula here, and we're being asked to make u the subject of the formula. Okay, so we've got it in terms of w at the moment, and I want to make u the subject. So what I'm going to do is I'm going to deal with the fraction thing first. So I'm going to multiply both sides by 2 take away u all squared. So that gives me w times 2 take away u, all squared is equal to 3. Okay, I'm now going to expand this. So w times, and if I expand 2 take away, no, I'm not going to do that at all. Sorry, I'm not going to expand this. What I'm going to do is I'm going to divide both sides. So let's ignore that. Okay, I'm going to divide both sides by w. Okay, so that gives me 2 take away u squared is equal to 3 divided by w. Okay, so just to be clear, the reason why I shouldn't be expanding it is because I've already got u just mentioned once in this. So I don't, if I expanded it, I'd have u mentioned more than once, and I don't want that. Okay, so u's already mentioned just once, so I'm not going to expand it. Okay, so I've now got 2 take away u all squared is equal to 3 by w. So my next step now is I'm going to square root both sides of this. Okay, so I'm going to square root both sides, so that's going to be 2 take away u is equal to, and this is where I need to be careful, because I'm solving an equation and I've got something squared and I'm going to square root both sides to solve it, then, or to rearrange it in this case, then I need to make sure that I've got a plus or minus there. Okay, because that could be a positive or a negative. Okay, and then finally I need to, or not so finally yet, I need to add u, so I'm going to subtract 2 from both sides. That gives me negative u is equal to negative 2 plus or minus the square root of 3 over w. Okay, and then essentially I'm going to now multiply both sides by -1. So if I multiply u by -1, it's going to be u. If I multiply -2 by -1, it's going to be 2. And if I multiply this by -1, because it's plus or minus, it's still just going to be plus or minus. So it's going to be plus or minus 3 by w square rooted. And that there is going to be my answer. So u is equal to 2 plus or minus the square root of 3 by w. Okay, question 11. We're given the first 5 terms of an arithmetic series and we want to find the 51st term of this series. Okay, the first thing I'm going to do is we're going to work out what the nth term of this is. So we can see that we're going down by 4 each time. So I know it's going to be -4n. And the first number in my -4 times table would be -4. But this is -2. So I can see that this is actually 2 more than -4. So the sequence is going to be -4n plus 2. So I'm just going to try that for the 5th term. So the 5th term is this one here. So that should be -4 times 5, which is -20. And -20 add 2 gives me -18, which it is. And I can see that my nth term works. Okay, I want to find the 51st term of this sequence. So I want to know what's going to happen when n is 51. So that's going to be -4 times 51 plus 2. So -4 times 51 I know is going to be -204. So I want to add 2 to -204, which that gives me -202. So the 51st term of this sequence is going to be -202. Okay. Part B says find the sum of the first 51 terms of this series. So I know what the 51st term is, but I want to find the sum of all of those up to the 51st term. Okay, so I want to use my formula here, and that's going to be, and the formula I'm going to use is going to be a half n times, and because I know the first term, which is -2, and I know the last term, which is -202, I can just do a plus l. Okay, so I'm going to use that version of my formula. Okay, I'm just going to write down the information I know. So I know that a is going to be equal to, and it's my first term, which is -2. I know my last term is going to be -202. And I also know the number of terms, and that's going to be 51. So I'm now going to put all of that information into this formula. So the sum of the first 51 terms is going to be equal to a half of n, which is 51, times by a plus l. So that's going to be -2 plus -202. So that's the same as take away 202. Okay, I can simplify that because I've got a half of 51, and -2 take away 202 is going to be -204. Always take your time and just make sure that you've got those calculations correct. Okay, right. So now I want to do half times 51 times -204. When I'm multiplying three things together, it doesn't matter which order I multiply them. So I'm going to do the half times the -204 first, because I know that's going to give me -102. So this is going to be 51 times -102. Okay, so now I just want to carry out this calculation here. So I could actually do this in my head, but I'll set it out in a different way for you, just so you can see how you might be able to do this. So 51, I'm going to partition it into 50 and 1. And -102, I'm going to partition it into, well, it would be -100 and take away 2, yeah, because that there gives me -102. So I've done this just to make the calculation a little bit easier for me. So I've got 50 times -100, which is -5,000. 50 times -2, which is -100. 1 times -100, which is -100. And 1 times -2, which is -2. So that gives me -5,000, take away 100, take away 100, take away 2, which is 5,202. Okay, so my answer for that is going to be negative 5,202. This calculation here, though, you just do that in any way that you feel comfortable. Okay, so I'll just shared you one way of doing it, but obviously just do it in the way, whichever way you feel comfortable doing it. Okay, and that's the answer to that question there. Okay, question 12. We've been told to complete the table of values for y is equal to this expression over here. And I'm being told in a second that I'm going to, on the grid opposite, so it's overleaf on this paper, draw the graph of this from values x from -2 to 4. So I'm going to take this information and then I'm going to put it onto the graph. Okay, so what I'm going to do is I'm going to substitute all my x values in here to work out my y values. So I could start anywhere, but I'm going to start on this side. So I'm going to start with the positive numbers first and then do that negative number last. So over here, I'm going to substitute the x for the number 3. Okay, so that is going to become, instead of 2 take away x, it's going to be 2 take away 3, which is -1. So I'm going to have -1 over 2, which I'm then going to cube. Okay, so I've just replaced that x with the 3 there to get my -1. So -1 halves cubed is going to be -1/2 times -1/2 times -1/2, which is going to give me a negative value, and it's in fact going to be -1/8. Okay, so I'm going to get -1/8 for that. Now, because I want to plot these onto my graph, I'm going to write that as a decimal, and I know that 1/8 is 0.125, so this is going to be -0.125. Okay, this one over here, I'm now going to replace the x with a 2, so I've got 2 take away 2, which is 0, and then I've got 0 halves cubed, but I know that the value of this is just going to be 0. Okay, so I'm going to have a 0 in there. The next one, I've got a 1 that I'm going to replace it with, so 2 take away 1 is 1, and then I've got 1/2 cubed. Okay, and that's similar to this one over here, but this is going to be a positive, so it's going to be 0.125. Okay, because that's just going to be an 1/8 again. Okay, the next one, this time my x is 0, so I've got 2 take away 0, which is 2, and then I've got 2 divided by 2 cubed. Okay, and that's essentially just going to be 1 cubed, which is just 1. Okay, this one's already done for me, so I'm going to do this one. So this time I've got 2 take away -2, so that's going to be the same as 2 plus 2, which is 4. So I've got 4 by 2 cubed, and 4 by 2 is 2, so this is essentially just going to give me 2 cubed, and 2 cubed is 2 times 2 times 2, which is 8, so we should have an 8 in there. Okay, so I've now completed my table of values, and I get 2 marks for that there. So it's now asking me to draw the graph of this, so I'm going to do that now. Okay, so to save time, I've drawn out the axes, and then you need to make decisions around doing this yourself. So I'm just going to show you how I did this. So I can see that on my x-axis, I've got the table down here so we can see it. I went from -2 to 4. So I need to make sure that on my x-axis, I can go from -2 to 4. And I aim to make it as big as I can. Okay, so I knew that I'd be able to fit in all of my values if I used every 2 big squares to count for 1 unit. Okay, and then on my y-axis, I need to go from my lowest value to my highest value, because I want to be able to plot all of the values that are there. So the lowest value I can see is -1, and the highest value I can see is 8. So it's going to go from -1, and I've actually taken it one more, I've taken it to 9, okay? But I just needed to make sure that I can fit this in, okay? And obviously that's the origin, so that's where the 0, 0 will cross each other. Now, we need to just be careful here, because I've used 2 big squares to count as 1 unit here, but just 1 big square to count for 1 unit here. So that means each of these small squares here are going to be worth 0.2, and each of these small squares here are going to be worth 0.1. Okay, so I just need to bear that in mind when I'm plotting this. Okay, so I'm now going to plot my points. So you should use a pencil for this. I'm using a pen just so you can see exactly what I'm doing, because it might not come up on the screen. So I've got x is -2, y is 8. So I'm going to have the coordinates -2, 8, which means I've got a point that's going to go up here. Okay, and just be as accurate as you can when you're plotting these. So I've got -1 and 3.375, so there's -1. So 3.375 is going to be roughly 3.4. I want to be as accurate as I can, as I said, but I'm not going to be able to be perfect with it. So I'm going to plot that point there, which is roughly 3.375. Okay, and then I've got 0, 1, that one's easy. I've got 1, 0.125, so there's 1, 0.125, it's positive, so it's going to be before the 0.2, so it's going to be about here. I've then got 2, 0, that one's easy again. 3, -0.125, so that's going to be just there. And then I've got 4, -1, which is going to be down here. Okay, so I've got, and I can see that I'm going to get a curve that looks a little bit like this. So I'm going to be brave here and I'm going to try and draw this in my pen. So I might mess it up slightly. Let's see what happens. Okay, I'm happy with that. I'm happy with that. Okay, so it should be a smooth curve. Right, okay, so now I've plotted the graph. So you get marks for this, for ensuring that you've plotted all the points correctly, and then you get a final mark for making sure that you draw a smooth curve through it. Now we do actually need this again as part of this question, so we're going to come back to this graph in a second. Okay, so part C in this, we've done part B. Part C says use your graph to find an estimate for the solution of this here. Okay, so we're using our graph, which is y is equal to 2 take away x over 2 cubed, to find the solution to this. So what you should spot is that this and this look the same, but instead of having a y over here, I've got a 2, okay? So what I'm saying here is the y is equal to 2. So to find an estimate for the solution, I'm just going to draw the line y equals 2, and that's going to help me find an estimate of that solution. So back over here now, I'm going to draw the line y equals 2. So all I need to do is just draw, and the y equals 2 line is going to be horizontal, and I just want to make sure I get this in properly. Okay, and I'm just going to draw that line in. That's the line y equals 2. And now I'm looking to see where this crosses over here. Okay, and I think that this is at -0.5. Okay, so the one that you've drawn might be slightly different, but I make it -0.5. So I'm just reading off this value here. Okay, so this is the line y equals 2, and at y equals 2, we'll draw a line so that we can see it clearly. I've got x is equal to -0.5. Okay, so we'll go back to my graph again, sorry, my question again, and here I'm going to say that my estimate is going to be, this is going to happen when x is equal to -0.5. Okay, so essentially what we're saying is if I put a -0.5 into here, and if I work that out, I should get something that's going to be roughly 2. We're just estimating. Okay, now the second part of this is a little bit trickier, because this time this doesn't look perfectly like this. Okay, so I've got 2 take away x cubed is equal to 48. Okay, so that's a little bit different to what I've got over here. So I'm just going to rewrite this down here so we can see what we're doing. So we've got y is equal to 2 take away x over 2 cubed. Okay, so I want it to look like this. So what I'm going to do is I'm going to separate these bits out, and I'm going to have 2 take away x cubed on the numerator and then 2 cubed on the denominator. So that's going to be 2 take away x cubed, And on my denominator, I'm just going to have 2 cubed. And I know that 2 cubed is 2 times 2 times 2, which is 8. Okay, so this and this mean exactly the same thing. So I want it to just be 2 take away x cubed. So I'm now going to multiply both sides by 8. And that tells me that 8y is equal to 2 take away x cubed. Whoops, just gone off the screen there a little bit. Okay, so we've multiplied both sides by 8 and I've got this over here. Okay, let me move this up a little bit. Right, so I've almost got something that looks like this now, okay, but instead of 48, I've got 8y. So this 8y here, I need to replace it with the 48, okay, so that means that 8y is going to be equal to 48, in which case y is going to be equal to 6, okay, so what I'm saying, if the y was 6, then that would be 48, and 48 would be equal to this, which is what I want. So the solution to this is going to happen when the y coordinate is 6. Yeah, so when the y is 6, that's going to be 48, and I'm going to have this equation here, and I can use it to work out what x is. So I'm going to draw the line, back on my graph again, I'm going to draw the line y is equal to 6. Okay, so like I did before, I drew the line y equals 2 earlier, I'm now going to draw the line y equals 6. Okay, and then we're going to read off the x value from that. So I'm going to draw this across, y is equal to 6, get there, and I want to read off this x value here. Okay, so let's try and be as accurate as I can here. Okay, and I make that's negative 1.5, so I make this negative 1.6. Okay, so I'm going to go with a negative 1.6 for this one here. So my solution to this is going to be x is equal to negative 1.6. Okay, there you go, and that is question 12. Okay, question 13. We're being told that the straight line L has equation y is equal to 4x plus 1. We're also being told that L is the tangent to a curve at the point P with coordinates 1, 5. Okay, so we've got a curve that has a point on it called P that has got coordinates 1, 5, and this is going to be the tangent to it. We want to find an equation of the normal to the curve at P. Okay, so we've got the tangent, but we want to know the equation of the normal, and we need to give our answer in this form over here. Okay, so the first thing we want to do is, well, I know that the tangent has a gradient, and because this equation is the tangent to the curve, then the gradient of the tangent here is 4. And I also know that the normal is going to be perpendicular to this. So the gradient of my tangent, so I'm just going to call that m with a subscript of t, that is going to be equal to 4. That's the gradient of the tangent. The gradient of my normal, and I'll do that with a subscript of an n for normal, is going to be, well, if that's 4, this has to be perpendicular, so it's going to be the negative reciprocal of 4, so that's going to be negative 1/4. Okay, so that's going to be the gradient of the normal. So I need to find the equation of the normal, and it's at point P, so it's at this point. So I'm going to start by saying, well, I know that it's going to be in the form y equals mx plus c, and I know that that's negative 1/4, so it's going to be negative 1/4 x plus c. Okay, so this is going to be the equation of my normal, but I need to know what that c is. I know that this is going to go through the point P, okay, because it's going to be normal at P. So when x is equal to 1, I know that y is going to be equal to 5. So I'm going to write that down. When x is equal to 1, y is equal to 5. So I'm now going to substitute these values in. So instead of y, I'm going to substitute in the 5. And then I've got x is 1, so that's going to be negative 1/4 times 1, which is just negative 1/4, plus c. So I should now be able to work out what c is, because I'm going to add 1/4 to both sides. So I know that 5 is going to be the same as 20 quarters. So I'm going to do 20 quarters, add 1/4, which gives me 21 quarters. Okay, and that's going to tell me what C is. So C is going to be equal to 21 quarters. So when I can now put this value into here. Okay, so I've now got the equation y is equal to negative a quarter x plus 21 quarters. Okay, so normally we'd be finished here, but because we're being told here, give your answer in the form ax plus by plus c is equal to 0, where a, b and c are integers. So I need to now change this so we're only dealing with integers. Okay, so the way that I can do that is, because I've got a common factor of 4, I'm just going to multiply through the whole thing by 4. So instead of y, I'm going to have 4y. Instead of negative a quarter, I'm going to multiply it by 4, and that's going to give me negative 1 or negative 1x or negative x. And 21 quarters multiplied by 4 is just going to be 21. Okay, so now I've got integers everywhere, but I'm going to now rearrange it so it's in this form. Okay, so I'm going to add x to both sides. So that gives me x plus 4y is equal to 21. And I need it to be equal to 0, so I'm also going to subtract 21 from both sides. So that gives me x plus 4y, take away 21 is equal to 0. And that there is going to be my answer. X plus 4y, take away 21 is equal to 0. And there we go. Okay, question 15. We're being asked to write this equation in this form over here, where a, b and c are integers. Okay, so essentially we're trying to turn this into a quadratic equation. Okay, so let's start by looking at this, and I'm going to deal with the fraction part first of all. So I'm going to do that by multiplying both sides by 2. Okay, so that's going to become x take away 5 squared is equal to 2x. Okay, I'm now going to expand this so that I can write it in this form over here. So I want to do x take away 5 times x take away 5. Okay, so we can write that out as double brackets over here, and in fact we will do that. So we've got x take away 5 times x take away 5. Okay, and if I expand this out, I get x squared take away 5x take away 5x plus 25. Okay, so that gives me x squared take away 10x plus 25. So I'm going to write that over here. X squared take away 10x plus 25. And that's going to be equal to 2x. Okay, so finally now, because I want it to be equal to 0, I'm going to subtract 2x from both sides. And that's going to give me x squared take away 12x plus 25 is equal to 0. Okay, and that will be my answer for this first part. Okay, so as you can see, a, b and c are integers. Okay, I'm now being told to hence, so the word hence is important, hence solve the equation, this equation. So what that word there is telling me to do is to use the information from here to solve this equation. Okay, so you might spot that this equation is essentially this equation over here. But I've rewritten this equation like this. So essentially this and this is the same, so I just need to solve this equation. So I'm going to write this equation down over here to show that's what I'm going to solve. Okay, so because I want to write it in this form over here, it's telling me that this is going to have an irrational solution, which means it's not going to factorize. So I probably want to use the quadratic formula. So I can complete the square and do it that way, but I'm going to use the quadratic formula for this one. So I'm just going to remind myself what the quadratic formula is. X is equal to negative b plus or minus the square root of b squared take away 4ac all over 2a. Okay, so I've written that down over here. And just to remind me of what it is, I'm now going to write down the values of a, b and c. So I can see from here that a is equal to 1, b is equal to negative 12, c is equal to a positive 25, and I'm also going to write down the value of the discriminant, b squared take away 4ac and that's going to be equal to, so b squared is going to be 144, because it's negative 12 times negative 12, take away 4 times a, which is 1, times c, which is 25. So that's going to be 144, take away 4 times 1 times 25 is 100, and that gives my discriminant a value of 44. Whoops, I've just gone off the screen there, but hopefully you followed that. Okay, so now that I know the value of the discriminant is 44, I can substitute all of this into my quadratic formula. So I've got x is going to be equal to negative b, so that's the negative of negative 12, which is a positive 12, plus or minus the square root of 44 all over 2a, which is 2 times 1, which is 2. Okay, so I haven't quite got to this form over here. Okay, so here I've got p plus or minus root q, and there's nothing that it's been divided by. So I'm having a check over here again, and what I've spotted is that root 44 actually simplifies, because it's the same as the square root of 4 times the square root of 11, which is going to be 2 root 11. So I'm going to rewrite this now as x is equal to 12 plus or minus 2 root 11 all over 2. Okay, so I can now simplify this. It does simplify because 12 divided by 2 is 6, and 2 root 11 divided by 2 is just 1 root 11, or root 11, so it's going to be 6 plus or minus root 11. Okay, so my answer for this is in fact going to be x is equal to 6 plus or minus root 11. Okay, and then that's my answer for that part. Okay, part B, over here. Being told that I now need to write x squared take away 6x take away 16 in this form over here. Okay, so this seems to be unrelated to the previous question. So I want to write this in, and this is essentially just completed square form. Okay, but I'm being told m and n are integers. Okay, so we just need to make sure that we've got whole numbers. Okay, so I'm going to do this by, well, I need to halve this number here, so that's going to become 3. So that's going to become x take away 3 squared, and then I want to take away the 3 squared, or the negative 3 squared. Okay, so negative 3 squared is 9, so I'm going to take away 9. Okay, this part here is always going to be take away. I then want to subtract that 16. Okay, and then I've got, if I simplify this, I've got x take away 3 squared, and then I've got take away 9, take away 16, and that's going to be take away 25 altogether. So this first part over here, I'm going to have x take away 3 squared, take away 25. Okay, part 2, again, it's used the word hence. It's saying hence, using your answer to be part 1, solve the equation x squared take away 6x take away 16 is equal to 0. Okay, so this is the expression I had over here, but this is now an equation where it's equal to 0, and want to solve the equation using what I've done over here. So what that's telling me is that I want to replace this x squared take away 6x take away 16 with this completed square form over here and make it equal to 0. So I'm going to rewrite this as x take away 3 squared take away 25 is equal to 0. Okay, so this and this means the same thing. I've just written this part in completed square form like I did earlier. Okay, so we're now going to solve this equation from completed square form. Now remember, we can do this because the x is only mentioned once over here, so I should be able to undo everything that has happened to the x. Okay, so the first thing I want to do is I want to add 25 to both sides. So I've got x take away 3 squared is equal to 25. Just added 25 to both sides. The next part, I'm going to square root both sides. Okay, so because that's been squared, I'm going to square root. So that gives me x take away 3 over here is equal to, and I need to be careful here because I'm square rooting 25, which I know is 5, but it's going to be plus or minus 5. Okay, I'm going to get plus or minus 5. Okay, and that's really important because 5 squared is 25, but also negative 5 squared is also 25. Okay, so x take away 3 can be equal to either. I'm now going to work out what x is by adding 3 to both sides. So that's going to tell me that x is equal to, and if I add 3 to both sides, that's going to be plus or minus 5 plus 3, but I could write it as 3 plus or minus 5. Okay, so I'm going to get two solutions here. Once where I use the plus and once when I use the take away. So I've got x is going to be either 3 plus 5, which is 8, or x is going to be 3 take away 5, which is negative 2. So my two answers are going to be x is equal to 8 or x is equal to negative 2. Oops, and I've just gone off the screen there, but there you go. Okay, question 17, and we're going to do some surd work here. So we're being asked to simplify this expression over here. So I've got root 3 plus root 3 squared plus root 3 cubed plus root 3 to the power of 4. Okay, let's then work this through. So root 3, I can't really simplify that, so I'm just going to leave that as root 3. Okay, and then I'm going to plus root 3 squared. So root 3 squared means root 3 times root 3, which I know gives me a value of 3. So I'm going to plus 3. Okay, so that part there is now 3. Plus, and then I've got root 3 cubed. Okay, so that's going to be root 3 times root 3 times root 3. So root 3 times root 3, I've already decided that is 3. And then I'm going to times it by another root 3. So I'm just going to get 3 root 3. Okay, so that bit is 3 root 3. And this bit here, I've got root 3 to the power of 4. So that's going to be root 3 times root 3 times root 3 times root 3. So root 3 times root 3 part we know is 3. And then I'm going to times it by another root 3 times root 3. So I'm going to times it by another 3. And 3 times 3 gives me 9. Okay, so this bit here is going to give me 9. So I've now got something that does simplify because I can see that I've got some like terms. That root 3 and that 3 root 3, they're like terms. And altogether, if I add those together, I'm going to get 4 root 3. And then I've got this 3 and this 9 that are like terms, and altogether that's going to give me 12. So my answer for this whole expression, if I simplify it, I get 4 root 3 plus 12. I can't simplify it any more than that, so that is going to be my final answer. 4 root 3 plus 12. Okay. The next part, we're being asked to simplify this expression over here. Okay, so there's a few ways I can do this, but what I'm going to do is I'm going to, each of these parts separately, I'm just going to rationalise the denominator because I feel like I'll be able to work easier with a rational number on the denominators if I'm adding those fractions together. So I'm going to start by doing this bit over here. So I'm going to rationalise the denominator of that part there. So I'm going to rewrite it as 1 over 2 take away root 5. And I'm going to multiply the numerator and the denominator by the conjugate of this, which is going to be 2 plus root 5. Okay, so remember, this keeps the fraction the same because essentially I'm just multiplying it by 1. Okay, so let's work this through. So I've got 1 times 2 plus root 5, which is just going to be 2 plus root 5. Okay, because I'm just multiplying the numerator by 1. Now the denominator, a little bit more work involved. So I've got the 2 times 2 bit, which is 4. I've got 2 times positive root 5. And then I've also got this 2 times the negative root 5. So that's going to be plus 2 root 5, take away 2 root 5. Those two bits will cancel each other out, so I'm not going to write them down. And then I've got a negative root 5 times by positive root 5. So root 5 times root 5 is 5, but it's going to be negative, so it's going to be take away 5. Okay, so I'm going to end up with 4 take away 5, on my denominator. That gives me 2 plus root 5 over 4 take away 5 is negative 1. And I'm just going to tidy this up here now actually, because if I'm dividing by negative 1, then I can divide each of these by negative 1. So 2 divided by negative 1 is going to be negative 2, and negative root 5 divided by negative 1, sorry, root 5 divided by negative 1 is going to be negative root 5. Okay, so I end up with negative 2 take away root 5, and that's what that is going to be the same as. Okay, so all I've done is I've rewritten this, and it's going to be this. Okay, I'm now going to do the same thing for the second fraction over here. So here I've got 1 over 2 plus root 5. Okay, and again I'm going to rationalise the denominator by multiplying it by its conjugate, which in this case is going to be 2 take away root 5. So I need to do the same thing on the numerator as well. Okay, and again, essentially I'm multiplying by 1, so it's going to keep the size of the fraction the same. So like I did before, I've got 1 times 2 take away root 5, which is just going to be 2 take away root 5. And on my denominator, I've got the 2 times 2 bit, which is 4. This bit and this bit are going to cancel each other out. And then I've got a root 5 times, a positive root 5 times a negative root 5, which is going to give me negative 5. So it's going to be 4 take away 5. And again, that's going to be 2 take away root 5 over negative 1. And like I did before, I'm going to divide each of these by negative 1. So 2 divided by negative 1 is negative 2. This time I've got a negative root 5 divided by a negative 1, and that's going to give me a positive root 5. So this is going to be plus root 5. Okay, so this one has simplified to negative 2 plus root 5. Okay, so they're both representing the same thing, but we've just written them with rational denominators, which in this case just worked out to be 1, so there's no denominator. Okay, so I now want to add these two things together. Okay, so I'm going to add together, and I'll just write it out just so we're clear about what we're doing. So I'm adding together the two fractions. Okay, and that's going to be equal to, well, I've already decided that this fraction over here is the same as negative 2 take away root 5, so I'm going to replace that with negative 2 take away root 5. And this fraction over here is going to be negative 2 plus root 5, so I'm going to add negative 2, which is take away 2, and I'm going to add a root 5. Okay, so this and this mean the same thing. I can simplify this now because I've got like terms again. I've got a negative 2, take away another 2, so that gives me a negative 4. I've got a negative root 5 plus root 5, and they're going to cancel each other out. Okay, so I am just going to end up with an answer of negative 4. Okay, so just to be clear, what I'm saying is that if I added these two fractions together, the answer that I get is a rational number, and it's just going to be negative 4.